All right, so I hope everything is working now. So yeah, welcome to the guest part of our lecture. So I'm very excited today to have Julia Schwarz to be our speaker. Yeah, Julia is a principal software engineer at Microsoft HoloLens. She has been working for Microsoft quite a while. She did her bachelor's in University of Washington and her PhD at Carnegie Mellon University, and a couple of internships at Google, Microsoft also before. And Julia has been working on user interactions on HoloLens. And if you have seen the demo of HoloLens 2, the introduction video of HoloLens 2, you have actually seen Julia already because she was presenting the new ways of using buttons interactively. And this is what she's going to talk today also in this talk. So I'm very much looking forward to see what she has to share with us. So welcome, Julia, and please go ahead.
Oh, thank you very much. And also thank you for having me. We're also live streaming this on YouTube. So I wanted to thank Martin and Federica for setting that up, especially because then if some folks missed it, especially people that even aren't in this class, they can see it later. So I'm really happy to. One positive thing from the coronavirus is that we are getting all this great content that's showing up on the internet. And also, the introduction actually did a pretty good job of covering me, so I don't think I need to introduce myself too much. I guess it's nice to meet everybody. And some things that I guess we didn't cover about me, just so you know who is this person talking to you. I'm currently talking to you from the Seattle, Washington area, so I'm in a different time zone. It's morning for me. The other thing to note is that something that's interesting, I know mostly we have an audience of students. I remember that very well. It was just 5 years ago that I was a student, PhD student, and that I actually started a company during grad school. And I'm gonna try to sprinkle in advice for students throughout the talk. And one thing I would highly recommend is to try to do that once in your life. Definitely a really intense and interesting experience. And what I did was to do machine learning for touch screens on phones. This is actually it's called tap sense or finger sense. We could detect by listening to the sound that your finger makes when you touch a phone, whether you're using your finger, your knuckle, and we ended up shipping a product where you could knock on your phone, and that's on most Huawei phones. If anybody has one and you try double knocking on your phone, it'll take a screenshot. So that's a little bit of background. I haven't always been in the space of interaction for 3D. There started actually in machine learning. So you can definitely, with computer science background, do many, many things. But that's not what I'm here to talk about. Today, I want to talk mostly about interactions in augmented reality. Specifically, I want to talk about the story of how we ended up getting these new interaction techniques on HoloLens 2, because I was there for most of it, or almost all of it. And just really quickly, in case some folks aren't familiar with what Microsoft does, and specifically the mixed reality team, which is the team that I'm on, it's a huge team. What we do in this space, we do many things, actually, more than you probably expect. So one is we work on hardware like the HoloLens 1 and the HoloLens 2. We also ship this thing called Windows Mixed Reality, which is the virtual reality, basically OS, actually a modification of the Windows operating system that supports VR headsets. So if you plug in a virtual reality headset into your computer, it will actually, Windows recognizes that and launches up a special UI. And I'm very familiar with the home that shows up. And if you ever move objects in the home, in that UI, I worked on a lot of that code. So we partner with a lot of companies to make virtual reality headsets. We have like a reference design. And then, of course, we ship HoloLens 2 as a first-party hardware product that we've made. So I know that HoloLenses can sometimes be a little bit still challenging to acquire just because of supply constraints. And many people may be familiar with virtual reality headsets, but not as much augmented reality. So just very briefly, in case folks aren't familiar, the difference mainly between a HoloLens or a virtual reality headset and HoloLens is that the HoloLens is see-through. So you can, basically it's like glasses that project content onto the world. And then additionally, it's standalone, which means no wires connected to your computer. And the HoloLens tracking is really exceptional. So the head tracking is just phenomenal in how stable the holograms are. And the HoloLens has some really impressive new sensors. Some of my favorites are the articulated hand tracking. So we use computer vision to track 25 joints per hand of your hands. And then also we have things like eye tracking, and through research mode, which some of you may be familiar with, I'll talk briefly about that later, you can also access many of the sensor streams that actually expose many of the sensor data that HoloLens gathers. Sometimes I kind of think of it as a Kinect. You might be familiar with Azure Kinect or Microsoft Kinect. I think of it as a Kinect on your head with an incredible display, but that's really underselling it. It's a really incredible product. Other things that the HoloLens 2 differs from the HoloLens 1 is that the HoloLens 2 is much more comfortable to wear on your head. And I usually code with it. So I'll be sitting and I can wear it all day and just be coding with it. And then it's got this really awesome flip up visor, which is also great for coding because you can flip up the visor, do your work, and then flip it down and test your work. So just really briefly, since not everyone's familiar, I promise we'll get to more stuff soon. And then the other thing that we do is software. And I didn't really know this until I joined Microsoft, but there's actually multiple parts to that. So one is we work on the platform or the operating system. And that's what I worked a lot on, is we call it the shell. So that's the main user interface, the equivalent of the desktop on a Windows PC, but for HoloLens. We call it the shell. It's the thing that shows up when you launch, whenever you do a balloon gesture, and you see that panel that shows up, lets you launch applications. That's the platform. The platform also comprises of APIs in basically any sort of any API that you talk to that's from the UWP or Windows API. Somebody has to author that, and that's what Microsoft does. And then, of course, we also add software development kits and toolkits. So, for example, the mixed reality toolkit for the Unity and Unreal engines, we do a lot of the work there. We actually have many other toolkits, or several other toolkits. Then we also do first-party software. So that means software that we write for our customers. This mostly under the brand, I think, Dynamics 365 now. And these are things like Remote Assist and Guides. And we sell those normally to enterprise companies. Remote Assist is software that you can put on your HoloLens and then call somebody. If you're, for example, working on an elevator, you need to repair something, you need help from someone, you can call them and then get their first-person view. Or they can see what you see and then annotate in your world how you should fix things. Guides is sort of training software to help teach people how to do things in factories with the renderings, right there, because it's HoloLens. And then, as I mentioned before, we build a lot of sort of toolkits, like Mixed Reality Toolkit, for our customers. And we work a lot with our customers. I spent most of last year traveling the world and one-on-one helping customers take their HoloLens 1 solutions and update them to HoloLens 2 solutions, including customers in the medical field. So, yeah. Okay, so that's sort of a brief background on generally AR and VR. And this talk is titled Building Instinctual Interactions for HoloLens 2. And the term instinctual interactions is really catchy, but it may not be clear immediately what it is. So let me just quickly explain it to you, and then I'll talk about how we actually ship those. It's kind of, if folks are familiar with natural user interface from Kinect, the idea is a couple. The way that I would describe it to someone who doesn't have a computer science background is that you shouldn't need to learn how to use this interface. You should just know how to do it, because the interactions that you design mimic the real world. For someone who's more technical, to me, what that means is that the core idea of instinctual interactions is kind of like how touchscreen interactions, you're just directly touching content. With 3D content, you're just directly touching 3D content. And at the next level beyond that, beyond just that you should be able to touch objects, you shouldn't need to have one level removed from them and look and do an air tap, which is kind of what we had for HoloLens 1. We want to actually combine multiple modalities. So that's sort of the long-term dream and what we're working on. Combining the hands, voice commands, and the eyes and motion controllers together to sort of have the computer actually understand what you want to do and figure it out from context. But anyway, for HoloLens 2, I think the main thing to remember is that these are things that should be very easy to learn and use, and that the basic idea is that holograms, as much as possible, it'd be great if they can kind of react how you would expect them to, that you shouldn't need to learn or read a manual or documentation to know how to interact with something. My favorite story is like when I would put a HoloLens 1 on somebody and I tried to teach them how to click a button, it would take like 5 minutes. But with HoloLens 2, my favorite thing is you put it on. I put it on my nephew, he's 8. And I didn't even need to say anything. He just pressed the button and it worked. And that just, that's sort of, to me, instinctual interactions. You shouldn't need to teach somebody how to use something. So with that kind of background out of the way, I wanted to quickly explain what I want to cover today, and it's a lot, so I'm hopefully going to get through it all in 45 minutes. Since this audience is students, I really like to talk a little bit about my journey because I want to show you how you can go from being an engineer, like a regular software engineer, all the way to shipping this incredible product, and that it's very possible, and just show you all the steps along the way. And then I'm going to quickly describe the interaction principles, basically design guidelines for HoloLens 2. There's a lot of detail in there that is important to get right, but the good news is that we have tools so that you don't have to worry about those as much. And I'm going to talk about a lot of my favorite tools to use when prototyping for HoloLens, and also conclude with some food for thought later on. So I think we alluded to this presentation of the HoloLens 2 announcement video. We're coming up on 2-year anniversary of it, actually, which is incredible, in February, where I was really fortunate to get to the opportunity to reveal to the world what HoloLens can do and all of these instinctual interactions. And this was a very special moment because normally they don't let engineers give live stage demos. Usually they have the executives do that. And the reason it was so awesome is because all of these prototypes are things I actually built, and or myself and my team, of course, or not my team, but collaborators actually built, and I'm gonna show those to you, much less nice looking versions of them. But it's really awesome when you get the opportunity as an engineer to present your work. And if anyone hasn't seen this video, you can just search HoloLens 2 on YouTube or your favorite video search engine and have a look. And what I'm going to hope to talk about today is how I actually got here, because it wasn't like I auditioned. I'm not a great actor. I mean, maybe I'm an okay actress. I don't know. But it wasn't for my acting skills. It was because I actually made all this stuff. And so I'm going to show you how you can do that. And going back to just kind of why is this such a big deal, or why was I so excited about this? It's because to me, this, for someone who does user interfaces all the time, it's like an input paradigm shift. It's kind of like how we went, most of you are probably younger than me by now, so maybe you don't remember as much, only having a mouse and keyboard, but we went from only having point and click mostly to touch screens. And that was huge. I remember the first touchscreen demo I saw was from Jeff Hahn. He had a giant screen and he was doing multi-touch, and it was amazing. And that's kind of the same shift from an input paradigm of going and using your head, which is what HoloLens 1 did, and clicking with this gesture that's really hard to teach, to just directly pressing buttons with your hands. And of course, it's not just the UI that made this happen. It's huge leaps in tracking of articulated hands. So it's the culmination of many things that actually caused this to work well. All right, so the stage demo, how did that actually happen? As I mentioned, we got startup, joined Microsoft as an SDE2, just like a regular software engineer on a team, and they had me fixing bugs for like the first few months, I guess. They just, on day one, they're like, here's this bug, here's the Windows operating system code base, figure out how to fix it, and zero documentation. So that was a fun first week. And that was difficult, but very important, because you kind of cut your teeth, you sort of get this practice of learning the operating system, and you kind of understand when you work on the operating system as an engineer fixing bugs, how hard it is to ship features. And it kind of helped me understand that I couldn't propose an idea that was incredibly difficult to implement, because there's so many challenges just in getting it working with the OS and having things be reliable. So you kind of have to find this simplest this is a piece of advice. You want to find, when you want to come up with something really revolutionary, you want to express it in the simplest possible way and figure out the first version that you can ship that's as basic as possible. And really, touching holograms boils down to, you can press buttons and you can grab and move things, and that's it when you think about it. If we had started with trying to ship a fully physics-based system in the OS, that would be much more difficult, because on top of the actual research challenge of getting that to work, you also have the operating system challenge. So that's an important lesson right there. And so while I was doing all these incredibly challenging operating system bug fixes and features, also worked on building prototypes on the side, learning Unity. And because I knew when I joined that I wanted to ship touching holograms. So I did that in the free time. And the key, I think, difference between, so I have a research background, but the difference between me and most researchers is that I was like in the code most of the time. And I think that was very helpful and valuable. So I actually do recommend that, especially because you can contribute a lot, because you can do the code, but also you can bring in research. So it's really valuable. So how did we get to the stage demo? Well, I'm going to share many prototypes that we built. We built, like, I think almost 100 prototypes. Not going to show you all of them, but I'll show you the sort of prototypes we built, what we learned from those. And when we were working on the shipping version of the code, what we started doing is, I knew that we had to get energy behind it. So every month when we actually it was just every month, I would come up with what are the 4 things that we did this month, and I would share videos of, like, here's the first example of us actually touching a hologram, share them as broadly as I could. And it caught the eye of Alex Kipman, and he invited me to do an all hands presentation internally within our company, and that went well. And so he said, okay, next one's HoloLens 2 announcement. So it's because of sharing your work, which is another important lesson. I guess I'll have these lessons sort of sprinkled throughout the talk. So hopefully you can pay attention. I'll try to remind you so that you can pay extra attention. So another lesson is that it's very important to share your work. And I know it's very hard. Sometimes it can be very hard to share your work, but to take the time to make videos and share your work and share your learnings, because it will lead to to unique opportunities. And so I did that as much as I could early on. So that's kind of the bigger view. Now I actually want to dive into many of the prototypes that we actually built. These are the real prototypes. And I want to kind of take each prototype that we built and then share the learnings and how that turned into instinctual interactions. So let's get started. There's 2 parts, near and far interaction. Near interaction is the easy stuff, because that one's very obvious. To me, it was very clear that when we have a hologram in front of us, you should be able to directly reach out and touch it. So this was my hello world for HoloLens programming, actually, this demo, in the sense that it was the first program I'd ever written on a HoloLens to ship that worked in HoloLens for Unity. And so it took a very long time to figure out how to get the code to deploy, but I finally got it working. And back then, you couldn't actually really get close to holograms, in the sense that there was this thought that it would be so uncomfortable that it would just be very bad. So they would actually have this thing called a near clipping plane, where when you got close, like within 2 meters of a hologram, or maybe it was 1.5 meters, they would actually start clipping out the rendering. And so first thing I did is I removed that, because I wanted you to be touching them. And then the next thing is I changed the the cursor. So the cursor was no longer the head ray, the ray that comes from your head, but it was the hand position. I also figured out how to remove hand smoothing so that the latency was as low as possible for the HoloLens 1 hand tracking. And that's actually quite important because it makes it feel connected. You'll see the jitter, but that's totally worth the trade-off in this case. So this was the first example that I had seen and that many people had seen of actually the way that it could feel to directly kind of manipulate a hologram with your hand. And there's a couple things that made this demo successful compared to other ones that did similar things. I'd seen demos of people like falling cubes, and you could touch the cubes and they would kind of go off of your hand. So first of all, in this demo, the vertices follow your hand exactly. So they follow your hand as closely as possible. So that was important for making it feel connected. Another thing is I actually played a sound on grab and on release. So that audio feedback is very important. If you read The Design of Everyday Things by Don Norman, he talks a lot about system feedback, the importance of having your UI communicate to the user that it understands you. So sound is a big part of that. So if you play a sound on grab and release, then you can have confidence that the system gets you. I also did a color change for the exact same reason. That plus removing as much latency as I could made this demo really feel sort of connected, like when you were manipulating the content, when you were really like grabbing the object directly, even though this was just with HoloLens 1 hand tracking. So yeah, from this, we also I showed it to as many people as I could and got some feedback that it was kind of hard to know when your hand was near the object. So this is where more feedback would have been useful. So for example, some sort of a hover effect or a proximity light, although that is actually quite hard to do. We can talk about basically just using MRTK to do that later. Okay, so next we started to think about 3D UI controls. So this is actually the simple version of that HoloLens 2 announcement video, where what we did for this one is we kind of wanted to ask, how does it feel like if you can give people as many ways as possible to actuate controls? What's going to feel good and what won't when you have articulated hand tracking? Because we didn't know. So we tried to come up with as many ways as possible to push buttons, move sliders, turn knobs. So you can see each of these is a different technique. One is poking, one is pinch and grab. Another one you'll see is like rotating directly with your hand. This is the knob turn. We thought this would work really well, but it turns out that the sensor limitations and the lack of haptics actually make it not work well. We showed it to a lot of people and we asked them what felt good and what didn't. So from this, we learned a couple things. One is that pressing buttons feels really great. Also, pinching and moving things also feels great. And when we say great, we would ask, like, how confident do you feel? If you want to set something to a value, how confident does that feel? Things that didn't work as well were that knob where you had to rotate it to a certain value for a couple of reasons. One is that as you rotate your hand, you position your hand into an occluded state where it can be actually quite difficult to track. So that's something really important to think about when you're designing UI, is that you want it to be sensor friendly. Sensors can only see, think of it as a camera on the top of your head. So if they can't see your hands, it's going to be very hard for them to figure out what position your hand is. And so it's sort of this trick of you have to figure out how to design a UI so that your hands are nice and visible so that the tracking can be as accurate as possible. And then a lack of haptics also can make things like the knob and also the press knob quite difficult because you don't have a physical barrier stopping your fingers. With a pinch, you do. For things like buttons, what you do instead is you use audio and visual feedback to compensate for that. So you see lights, you hear a sound when you press, and that can help fool your brain a little bit into thinking that you've touched something. So kind of learned a lot from both of those prototypes around what is and is not working. And we came away with this with two basic ideas, and they're very simple. One is pressing buttons with your finger works. Seems kind of obvious, but there's more importantly, there's a lot of things that don't work. So the one thing that we land on that works confidently is pressing things works well. When you press things, it's very important to provide visual and audio cues. So we talked about proximity feedback for the Minecraft cube. It's really useful to have a spotlight effect so that you can know, you basically need to communicate that the finger is close to an object and its distance from the object, and also when it's contacting the object. And normally you want to provide sort of visual and audio feedback whenever contact begins and ends. So this can be, there's a lot of subtle detail that's really hard to get right unless you're an artist or a visual effects designer. Luckily, we have buttons that already do this. And there's a lot of like subtle effects in these buttons. This is in the Mixed Reality Toolkit MRTK. You can see the proximity light here. You can see this thing called a finger cursor, which I'll talk about later. And then you can hear the sound effects for a button on press and release. So I guess the point of that is that we practice what we preach, I guess. Okay, so pressing buttons. The next thing is kind of, I said the next basic idea from direct manipulation is grabbing and moving things. But how do you grab them? Do you incorporate the wrist rotation when you grab? And that was kind of something we wanted to think about. And then we also, of course, wanted to understand, well, how easy is it going to be to push objects around? How does that feel? And there was a lot of research on this before from other sensing systems. And we had a feeling this would be difficult, but there are some cases when it can work well. Like, for example, if you push an object and it's constrained to just one axis. So we built this task where this experiment where you have to put a crane in a box and also, you know, rotate boxes to put them in sort of targets. This is another tip for folks who are building prototypes and experiments, is that always design your demo so that somebody has something to do. And it's actually often overlooked, especially by engineers, but even designers. Most people don't think about this when they build a demo, is that if someone doesn't have a task to do, like put the crane in the box, then they'll probably just kind of bat things around for a little bit and kind of give you the kind of feedback of, oh yeah, it was kind of cool. Your demo was cool. But when you give them something to do, it allows them to repeat the same task in multiple different ways. This is normally how we would do it. We would, like with the dials and press buttons, we had many different dials of different interactions. And all of them had the same, I would say, like make the color halfway in between black and green or something like that. And so when they have something to do, they can kind of compare how different modalities work and give you much better feedback. Also, people's behavior changes when they're actually doing a real task versus just kind of playing around with something. So always give people something to do in your prototype. So from that manipulation experiment, came up with, again, another basic idea of grab things to move them. And using the wrist is great for inspection, and it can feel very good for a demo. If you want to be very precise, it's actually quite difficult to use the wrist to place things very precisely if you don't have something like snapping enabled, because as you grab something, when you release, your wrist will often move a little bit. So it can be quite difficult to get, you'll position something very precisely, and then as you release, the wrist will move and it'll move the object. And it can actually be quite challenging to look back in time and find that frame where you started the release. We tried that. It's harder than it sounds. So if you want a lot of precision, just look at the position of the hand. Don't use the rotation of the hand. Something also to note in this particular diagram that we observed is that the size of the object dictates how people grab it. Usually it's a lot easier to detect a hand that's nice and open with a pinch. So if you want maximum detection, you can provide small handles for people to grab. You can basically fool people into doing gestures that you want them to do by designing your affordances or the thing to grab to be very narrow, because then they'll grab it like this. If you give them a big object, they'll grab it with a fist, which can be a little harder to track. Or if you don't show any handles at all. So that's kind of a bonus trick. You can see in this illustration that usually when people have these small affordances to grab on the sides, they tend to be quite precise. So that's a kind of a trick that I use a lot in my prototypes. I give people handles to grab. Again, for precision, just use positional tracking. Don't use rotation. However, rotation is really great for inspection, and it demos very well. It can make the product feel like your hand is very connected to the object. Sometimes what we'll do is we'll have an inspection mode where you can kind of grab and inspect something by rotating it, and then when you release, it'll snap back to its original rotation. That's another trick that we do. When you do want to have like pushing objects around, physics is super promising but very challenging. When I say physics, I just mean push objects around for many reasons. One of which is that it's really hard to disambiguate a grab from a push. So as you try to grab something, if you also can push the object, you'll often push it away. I have seen things where it works quite well. But if you sort of want the biggest bang for your buck, just constrain the object. So keep it still in place and then rotate it on one axis, like I showed in the video, where you just have a slate that you can rotate just on one axis. That can feel quite good. Okay, so moving on to how do you sort of interact with browsers and maps, things that are 2D. There's a lot of that kind of content in most operating systems, so we had to support that. And we didn't know if you could just scroll like this. We didn't know if that would be successful. So we built a prototype to test it. Basically, most of this work is like, here's a very simple idea. Does it actually work? Because it's never been done before. We try it and we say, okay, yes, it can work, but there's a lot of detailed algorithms that you need to get the math right. So scrolling is one of those where it seems very simple, but because your hand doesn't move on an XY plane, it moves more in circles. If you plot the trajectory of a hand as you do a scroll, you'll notice it basically moves in circles. I did that actually visualizing in HoloLens, and I saw these circles. You need to like rethink your collider, your collision sizes for what's a valid touch, and then also your collision for releasing, and also the math that you're doing to actually translate finger movement into XY movement of the panning view. So the point is that this is harder than it looks, the panning interaction, because again, your finger isn't colliding with a surface. Makes a lot of things harder. An important point as a tip is that we found that having one point of interaction per hand active is much more reliable than, for example, having 2 or 5 points of interaction per hand. Why? So we tried for this pan map example, we of course tried pinch to zoom with your finger and thumb, and guess what? It's very hard because again, you don't have a physical boundary. It can get very hard if you sort of want to release with your hand. Usually what'll happen is your thumb will get stuck in the pan view still, and it'll keep moving something. So it's very hard to be precise. However, with one finger, it kind of one interaction per hand, it can kind of be enough. This is something that it would be amazing to do some more research on. For example, how can we figure out which finger joint should be active per hand? Right now, we always put it on the index finger. And luckily enough, that works pretty well. But this is, again, for reliability. We, of course, tried when typing all 5 fingers, and actually we tried all combinations of, like, all combinations of 2 fingers, 3 fingers, 4 fingers, and 5 to see if we could sort of make touch typing feel good. And it's a lot harder than it sounds. So that is a great research problem for folks who want to tackle a new challenge. Here's a demo of that, actually. I love the hand physics lab from the Dennis Kuhnhert. I forget the other person's name, but it's a great product to try on Oculus Quest. And I tried typing on their keyboard, and it was extremely difficult because all of the fingers were hot. Versus on a HoloLens, there's a reason why only 2 fingers are active at a time. And that's why. So that we optimized for reliability because we have an operating system that needs to, you need to be able to type in your email address. It's actually like the second thing you have to do when you put on a HoloLens, which is one of the hardest things to do. So it made me very happy when I gave it to my mom and she could do it, because on HoloLens 1, it was very hard for her. Okay, single point of interaction per hand. And the other, this was really interesting. This cursor is critical for successful interactions. Until we had this cursor built, the design of it, this is actually really great work by my colleague, David Calabrese. He sort of came up with the initial version of all of the effects, the lighting, the shadows, the subtlety of the ring going down to a smaller radius, and the color change on contact. Without this, it actually was really hard for people to feel confident in their interactions. They thought the entire system was broken. I would get all these bugs saying that hand tracking totally doesn't work on HoloLens. This is never going to work. And I said, just wait. And we added the finger cursor, and then all those complaints stopped. So the lesson there is sometimes people will think something's completely broken, and really it's just one thing that's missing, and you need to get that thing perfect, and just be patient. And this is that one thing, and it's the importance of feedback. Visual feedback on HoloLens is really critical, because you need to communicate distance to the object, because it can sometimes be hard to perceive where your hand is relative to content. So this cursor is really important, and luckily we have tools in Mixed Reality Toolkit for Unity and Unreal engines now that give this to you for free, because there's a lot of details to get right here. Okay, I have about 11 minutes to get through far interaction and tools. So we'll get started on that. So near interaction is much easier to have sort of be successful than far interaction. We actually spent a lot of time figuring out how do you interact with things at a distance. And we tried many, many different interaction techniques. And I think this one's harder because we don't really interact with things at a distance as much in the real world, except maybe with like remote controls. But we don't sort of interact with sort of our hands like we do here. So let me talk through many of the techniques that we tried for pointing with far interaction. One of them was finger. So we would draw a hand ray, kind of cast a ray from the eye to the fingertip and see what happens. And we learned from this is that pointing at things, so if you could combine a point with like a voice command, that would be great. But we really wanted that haptic feedback of selection of your one finger touching the other. And when you select, the finger just goes really far. The angular movement is just way too high. So that did not work very well. This is something that I get asked regularly, is why didn't we just have the ray come out from the wrist? And there's a good reason for that. We tried it. First of all, again, because we really wanted selection to be that haptic, comfortable gesture of the kind of fingers coming together, that's actually quite hard to get working with the wrist, because again, the wrist moves a little bit as you pinch. And you can mitigate things, but that adds latency, and latency makes things feel less sort of in control. So there's always that trade-off. The other thing is that the wrist is actually, you don't usually point with things using your wrist. If you think about a pen and how you hold the pen, how do I rotate this pen? I'm not actually moving my wrist at all. I'm rotating my fingers, and it's a learned, super learned, highly dexterous and like complicated movement. I don't do this. I don't have like flippers. I have fingers. So really what you want is a way to like have a pen or some sort of a pointer, virtual pointer, and figuring that out is quite challenging. So that's just something to think about in your head, is like, it's not about the wrist, it's about having something that you can, like a pen or something to actuate. Okay, this is one of my favorites that I love to share, is the flying hands, which was the first thing I thought of as how you should interact at a distance, is just have your virtual hands fly out when you're far away from an object. And I thought this was really promising for a long time, that when you're near, you just directly interact, and then far is the same exact interactions, except there's these virtual hands that fly out. I still think this would be really cool in a game or a one-off, just like your own application. This could work really well. For a system, what makes this hard is that it can be difficult to know where to fly the hands out to. Because if you have a giant web browser, you need to figure out which point on that browser do those hands go. How do you move them? I don't know. There's I think a lot of cool stuff here that I would love to see more work on. But we ended up not shipping it just because it was too hard to figure out where to put the hands and when to fly them out in a general sort of OS system. So in the end, the thing that was the most stable, and after testing compared to the head gaze cursor, the easiest to learn, was this ray that kind of we draw a line essentially from where we think your shoulder is to your palm, and the palm is one of the most stable joints on the hand. That's stable under pinch. And so we still think that this could, this to me is a far interaction as an area for investigation and research. I would love to see new work done here. But this is what we found was the easiest to pick up and the most stable. So that's what we went with. It also works very well for moving content. So there's one thing is you have to always not just click things, but move them. So you can always see that I have both objects to click and objects to move, because we do both of those things in HoloLens. And some things are easier to do with clicking than movement, for example. So yeah, for far interaction, we land with these hand rays that we expose at the system level. I remember many times when I had to advocate for that, as we should expose this at the system so that everyone can use the same algorithm. Otherwise, we'll have different hand rays in different applications. And so I remember working on that, and with the engineer that ended up implementing the hand ray a lot. So thanks to my team members for making that an API feature. Okay, so I've given you a lot of sort of kind of rules to follow for building UI. They're basic, but they can be tricky to implement. So how do you implement them in your own applications? I would recommend to use an engine like Unity or Unreal and use the mixed reality toolkit, which provides all those UX controls for you. And in fact, I myself and many of my colleagues, we literally worked to make them as similar as possible to the main operating system controls. We call it shell parity. And I would make a long list of bugs of make MRTK match shell parity. These things have to be exactly the same because we want people's applications to be as high quality as possible. So we spent a lot of time on this, and it's kind of releasing it for free, and you can have a leg up in your applications by using these. So the MRTK, for those that aren't familiar, is this UX toolkit. I think of it as a library of UX controls that implements a bunch of implements these instinctual interactions principles, buttons, manipulatable objects. There's a slider in there that I wrote for the Mobile World Congress HoloLens 2 announcement demo. That was the first version. That was the slider for that demo, made it into MRTK. And the thing I love about MRTK is that it's cross-platform, meaning you write the code in Unity, if you use the Unity version, and you can compile it to run on HoloLens 1, HoloLens 2, VR headsets, including things like the Vive and the Oculus Quest, just released in MRTK 2.5. And so if you only have, or just the Unity editor, so if you only have the Unity editor, you don't have a HoloLens, you can do all of the work there, and then if you then go in the lab and compile it and run it on your HoloLens and test it. But you can do most of your work without needing it. You can use a much cheaper headset, like a $100 headset with a Leap Motion on it, to do everything and then test on these expensive devices. So that's, to me, really important to make it accessible to everybody. You can look for this video online of all the features that MRTK has, but there's a lot of controls that this is the hand interaction example scene, by the way. That's the place to start. Hand interaction examples. Sorry, it's a little buried. You have to search for it, but that's what it's called, and that's what you want to look for. So these principles, how do they mirror themselves in MRTK? Single point interaction per hand maps directly to this poke pointer, which is the 1 point per hand that sends touch events and pointer events whenever you collide with things. For visual and audio cues, there's a lot of design work. We pulled in the author of the shader, who did the shader for the shell, and he worked with Cameron Micca, who did it in the MRTK standard shader, to get these really nice visual feedbacks. You can see it in the pressable button HoloLens 2 prefab. By the way, pressable button HoloLens 2 will also work on HoloLens 1 and in VR. It's super misleading, but it works on all platforms. All the controls, actually, we have regression tests to make sure that they run with all sorts of inputs, not just the articulated hands. So they have to work on HoloLens 1. They even work with motion controllers. We have tests for that. So one of our principles, it has to work on multiple platforms. We try our best. 2D interactions, we have a slate prefab. So again, I'm trying to point out that for this idea, here's the thing that you can open to see it working. So here's a slate platform. For manipulation, you want to use now the object manipulator, not manipulation handler. That's been deprecated. So object manipulator is a refactored version. And yep, so that sort of has your one-handed, two-handed interactions, near and far, seamlessly built. And again, a lot of math in there that we just sort of have done. For precise manipulation, you want to use the bounds control. That's the object again. I think it used to be called bounding box. Now you want to use bounds control. So I only have a couple minutes left, but I really wanted to talk about tools that I think are really valuable that many people don't know about in MRTK. That actually I helped contribute to, from all the prototyping that we did for these 5 years. Many of the most useful tools we put into MRTK for you. So in editor input simulation, this is really one of the most useful things, that you can bring up a simulated hand and do all of your interactions as if it was a real hand. So you can use the WASD keys and sort of the scroll wheel with the mouse. And there's now a help window that shows you sort of all these interactions. The other thing that's new, relatively new, is that you can put on a VR headset and use the Leap Motion hand tracking also to simulate with the hand. So this allows you to do much richer interactions without actually needing HoloLens, if you just need to get a Leap Motion. And in fact, a tip is that you hit Unity play mode, and then you put the Leap, you just put, you don't have to wear the headset, you just can put the Leap Motion right where your head is and do all the interactions like this. Maybe you could tape it to your head, I don't know. That allows you to do things without having to put the VR set on and off. Hopefully, if you do have a HoloLens, you're using holographic remoting. This is the fastest way to iterate on HoloLens, because it can take, if you're deploying things to HoloLens, that can take several minutes, and it's something that we should improve. But basically, this is the old way that mostly I had to, when I was doing stuff, we had to do it this way. You had to compile to Visual Studio and then deploy to HoloLens. Now you can just hit play in Unity as long as you're connected via holographic remoting, and you can see the scene in your HoloLens, and then pause and live, edit things and see them there. So here's some instructions that if you just search holographic remoting MRTK and your favorite search engine, there'll be really good instructions for how to do that. Here's another one that I found really valuable when prototyping is recording and playing back input. And many people don't know about this one. But you can basically do an interaction. You can do it on device even. So let's say you're trying to debug a really difficult interaction. You do the movement, you hit record, you do the movement, and then you hit stop. And then you can actually get that file from the device and play it back, load it in the editor. And so that you can exactly replicate what's the bug. So that's really valuable. And we have a pull request open right now to make that input recording system much faster, much more performant. Also, I find that recording to comma separated values, CSVs, is really useful. So there's the user input recorders example. I think I shared on my Twitter another sample piece of sample code for writing to CSV that you can just take for yourself. And then something I really like that's not for Unity, but it's HoloLens 2 research mode, lets you access all of the sensors. And there's a really great GitHub project called CV for HoloLens 2 or HoloLens 2 for CV that has lots of really useful tools for bootstrapping, like accessing all of that research mode data that I think Federica actually worked on. Many people that are running this class, I think, contributed to that. It's a really great tool. So in sum, I wanted to, since you're students, give you things to chew on yourself, problems to think about. One is interacting with objects at a distance. The flying hands is really interesting to look at. Think about, the whole thing about tools and how we manipulate tools. Obviously, it would be great if we have a physical controller, but what about having just the tools that you have with you, your hands? I love the work that's going on with using physics for hand interactions. Leap Motion did a lot of great work there, the hand physics lab. There's lots of great research there. I think that's fascinating. It's much harder in AR than in VR, so I would love someone to crack that. Low-calorie interactions is this idea that we shouldn't have to do these gestures, that it should be very comfortable and easy to do, because these interactions, you can often get tired with your hands out in front of you. And for me, sort of an engineering task that I think is really important is to reduce the time it takes from compiling your code to seeing it on a HoloLens as much as possible. I really miss web development where I can just like save and see my change. So that's something to think about as well. So takeaways, I think I gave a bunch of them in the talk, so hopefully it's on YouTube, you can kind of pick those out. But one of the important things to remember is feedback is critical for user interfaces. So compensate for the fact that you're not touching things by using lots of sound and visuals to communicate where the hands are relative to your objects. As much as possible, use things that are familiar to the real world. And then when thinking about how you approach work when you go into the industry or after you graduate, to always be building and testing things, sharing them and getting feedback, and share your work as much as possible. Take the time to share your work, make good videos, and share it with people. Leaving you with some links. Make sure to go to aka.ms/MRTK to access the MRTK site. I use that. I usually don't use web search engines. And then aka.ms/MR, you might not know about this, but that's the design guidelines. So you might want to remember that. And there's a lot of great documentation there. Basically, we've taken all of our ideas and put them into docs there. And that's it. So I'm happy to take questions. Looks like I clocked in a little bit over, but not too much. Here's a lot of links. Yeah.
Okay, thank you very much, Julia, for this great talk. Very exciting. So thanks a lot for sharing all these nice experiences of your work and your journey at Microsoft. It's really exciting, very cool ideas for creating all these user interfaces. I just wanted to say that, yeah, please, we make a Q&A session now. We also have people on YouTube. Please post your questions in the chat. We will go over them and yeah, and discuss all of the questions. Maybe I steal the first question before we get going. I once heard the analogy that a user interface is like a joke. So if you need to explain it, it is not that good. And I think that's quite important, and I think you're following a lot this philosophy to having like really very intuitive user interfaces, and I think you're quite successful with this kind of approach. How do you actually test and evaluate user interfaces? Do you have like a systematic procedure, or do you have like user studies? Like what is the way to find out whether a user interface is good or not?
Oh yeah, that's a great question. I think that okay, let me talk about how we do it in industry. In academia, it's very different. So I came from both worlds. In industry, what I do, so obviously I am trying always to find people to test my things, because I really can't test my own stuff, which is really hard now with COVID. So what we for example have is twice a week, Tuesday, Thursday, we have a group of people that work on interactions. We meet and we try each other's prototypes out, and we give feedback on what is and isn't working. So we download each other's files and we try those out. And what you look for, honestly, is you look for very obviously good or very obviously bad things. Most of the stuff that you build, it's kind of in the middle, where people are like, yeah, it's nice. Usually they'll say it's nice. But what you're looking for is like you're mining for gold. You have to find like the one thing where people say, oh my gosh, this blew me away. And it happens like once a year, honestly, really rarely. And so you look for that. You also look for, it's harder to find bad things because people will actually try really hard to make it work. So like they'll almost never tell you that something's bad, because they think it's their challenge for them to make it work. So what you really want is you want to look for the really obviously good things. So basically you build something and you show it to your friends or to your colleagues. And ideally it would be great if you could show it to people who've never tried a device before. That's really hard for us at work because we work on a lot of confidential stuff. So what we do run studies, but since we have, a certain amount of resources and time to do those studies, what we do is whenever there's uncertainty, whenever we have like a debate where some people think one thing and some people think another thing, then we'll run a study. We don't run it for every single idea. If something's obviously very good, we don't need to run a study to prove that it's good, because it's already good. Usually once it's good, we have like other, like for near interaction, we would do like, we knew that was very promising, but we would want to know like how people's hands move when they're grabbing different objects. So we would run a study to record their hand movements. And then we could turn that into training data for the hand classifier. And so yeah, we run studies only when there's debate or discussion. And we show things as much to other people. And we look for things that are really very strong positives. It's very hard to find things that don't work. And my approach has always been to I call it the shotgun approach. So you basically try as many things as you can very quickly and look for things to stand out. That works a lot better than spending a long time refining something, although that's also very important. It's just that can be very, I don't know, that's not what we did for touching holograms, I guess, for most of it anyway.
Okay, thank you. So we have one question in the chat on YouTube. Let me go over this. So Skiris is asking whether you can just use your Oculus Rift and develop test applications for HoloLens, if this is possible.
Yes. So the Oculus Rift, I believe, supports so it used to be OpenVR. Now I believe we're supporting XR SDK, and I believe Oculus. Well, even if Oculus Rift doesn't support that, you can definitely use OpenVR. And we have sort of, we call them data providers or services that hook into OpenVR in MRTK, and you can basically hit play and use your Rift. I would recommend also grabbing a Leap Motion, because the Rift I don't think has hand tracking. The Quest does, but the Rift doesn't. So if you want to do hand tracking prototyping, you can buy a Leap Motion and stick it on your Rift and do prototyping that way.
Okay, thank you. So let's ask in the audience. Maybe someone I see a hand raise.
Yeah. Hi. I had two quick questions, if I can. First of all, of course, thank you for the presentation. I found it very interesting. So the first question was about the FAR interaction. I'm a big fan of the hand raise. I use them a lot, even when the objects are near, because they're very useful. But also the FAR hand that you showed us before, I thought they were interesting. Have you ever thought like of a mix of them? Like, I think the very useful thing of the hand raise are the rays, the line. So maybe having the line connected to the hand to show better where the hand is, or something like that.
Yeah, so like the hand on a stick. I think I did try hand on a stick, but I don't remember. I think I probably did even try drawing a line from my hand to the articulated hand. And let me see if I can remember how that, I would say, I think it looked pretty weird. So part of it is that you have to make it look, for a general UI, it has to like feel and look comfortable, and that one like looked kind of strange. And then again, the challenge was always, when do you switch between the hand on a stick and like, when is the stick length 0 versus non-zero? Because actually it's actually really hard, like at what distance, and everyone's hands have arms are different lengths. So like knowing when to move it to stick mode or when to extend the stick out is actually kind of difficult. Because with a ray, you're always just casting a ray and projecting it onto when it hits a collider, that's the distance of the ray. That's the length of the ray. But with a hand, if you did that, your hand would bump into things all the time. So my answer is that we tried it, and it was just like hard to get right, I guess. But like I think that this is still something really worth exploring, because it's like really interesting. I don't know. Yeah.
All right.
So it's worth trying again. Yeah. Next one. Did you have another one?
Yeah, like a very quick one. Like you showed us a lot of very interesting features that you spend time on developing. Like, is there something new, interesting feature you're working on right now?
Of course, but I can't talk about it. Yes, of course I'm working on features. I spent a lot of time in the last year actually working on MRTK, because we shipped HoloLens 2, but if you were writing your own application, you wouldn't have access to all those user controls. And I would love to talk about what I'm working on now. Maybe maybe sometime in the future.
All right. Yeah. Thank you very much.
Do we have more questions in the audience? Please don't be shy. Go ahead.
Hi. I also would have a question for Julia. Thanks for the presentation. I have You said in the beginning that the hand motions are not consistent if you are touching, or if you would touch a real surface, for instance. Do you also have, I don't know, in this near interaction, do you have insights on what improves even more, or how off is the hand interaction compared to a real interaction with the surface if you touch it?
I can tell you that when the hand is fully visible, so like this, the camera sensors really like nice visible open hands. So from my point of view, this is a very like nice open hand. They like pinches where you can see the finger and thumb. Maybe a good heuristic would be to optimize for all the joints visible as much as possible. So that's what makes tracking good when things are hidden from the camera. So if I do a pose like this where you can't see like my pinky and ring finger, that's where things get noisy, because then it's using prediction, or it's guessing basically. And so the way that you can kind of, if you design your UIs to encourage people to do gestures that are friendly to the camera, then that's a tip. And then I think I missed the second part of your question.
I was more interested if you also looked into how different the interactions are if you compare interaction with virtual objects and compared to with real objects. So if I don't have I don't have haptic feedback, I only have visual feedback and audio feedback, how different is the interaction then?
They're really, yeah. So we never ran any studies. That would be very interesting, like from a research academic perspective, to compare. One thing that I talked about a little bit in the talk that I did look at was just when you interact with a flat surface with a touch screen, you're moving along a plane because you're physically hitting it. Versus when you're in the air, the hands move in these arcs. And this also happens for buttons, and it's really interesting. So a button, if you press a physical button, it pretty much stops at a position. It makes it much easier to build hit testing. With a in-air button, I have captures where I would have this really great user who like nothing worked for this person, because they would move in really interesting ways. So when they pushed a button, they would go like, let's say the button's here, it would actually go arc and completely down and then out. So people's fingers go way beyond the bounds of a button. So that's why the colliders usually are huge for them. And in fact, you usually increase the collider size when you enter a button, so that when someone's finger goes in and they usually will move outside of the bounds of the button to do a press, especially newer users. And then the other thing that might happen is that when they release, so when they pull back out of the button, it might not be through the same area that they entered. So they think that they released it. But if you had a naive implementation where you just looked at the movement within a small region, you wouldn't capture that. That's another example. It actually makes button pressing really hard to do well. And then there's just like I have a coffee mug here. If you look at the way I grab a real mug, I'm framing this hand, and whereas if it was in the air, people just make a fist. This one's actually easy, but we did experiments where we would watch how people grab much larger objects, and they often will try to pick something up from the bottom and carry it. So they're very, very different. The movements are very different, and it's usually much more exaggerated.
You mentioned multimodal interaction. Do you think that, for instance, the eye tracking can help? I mean, I know that you use it for the opening of the main menu, which I think is really cool because you have haptic feedback, and also it's there in the periphery, or it's not there. It's only there if you look at it, the button. Do you think this can be used in, or are you? I think you're planning on this, or you're doing experiments how this can improve this kind of interaction, or the precision of the interaction.
I think eye tracking is really fascinating. I think it definitely is very important. And we have a lot of examples of eye tracking. Sophie Stelmach has done a lot of great work in that area, and she has made many examples in MRTK for eye tracking that are kind of like basically her experiments when she was as she was doing eye tracking. And yes, I definitely think that that's very important.
Okay, thanks.
Do we have further questions?
Yes, briefly. Hi, thanks for the talk. Is pretty cool. So in terms of what the HoloLens 2 shell actually is, would it be accurate to describe it as a kind of OS crossed with the game engine?
Sorry, can you repeat that? I didn't quite hear it.
Yeah, sorry. So in terms of what the shell actually is,
Yep.
so would it be accurate to describe it as the kind of OS crossed with the game engine, because it deals with like rendering?
Yeah, because we have to do with 3D rendering, 3D math. Yes, I would say that's accurate.
Okay, cool. So what were the kind of most like interesting or challenging features which you had to work on it? Shell features.
Shell features. So for me, the keyboard was pretty tough. There's many like things that make the keyboard hard. One is like you don't think about it, but so something that many people probably don't know is that when you launch the keyboard, like in your own app, it shows up, and that's the system keyboard, and that's rendered as an overlay. So we render your game, and then we have to render your keyboard on top of it, render the system keyboard on top of it. And that's like two renders. I don't know the details of the graphics pipeline, but that's like a lot of time for the renderer to run. So that was really challenging. And also we were talking about how do fingers move differently in real world versus when you're doing in air, and the keyboard is like a classic example of we would have a lot of these debugging visualizations where we would look at how the fingers move as you're typing, and they like the region where you enter a key and where you exit are completely different. So we had to do a lot of like, actually I worked with my colleague Jason, who did most of the like detailed engineering of the keyboard, and he did many like things to make that keyboard work well. And then there's also the visual and audio design of the keyboard that Alex Goff worked on. So that was one of the most challenging UI features to do. Yeah.
Cool, thanks.
We have another question in the YouTube chat, actually, so from Summer Lefebvre. Do you know if MRTK is used in the video game industry? Because he's saying he can't wait to test it with the Oculus Quest 2.
Yeah, I'm glad that you can't wait to test it. Yeah, the Quest work was a collaboration actually with a community member, Eric Provencher, he made his own like port of Quest for MRTK, and then we pulled it into the mainline MRTK. So that's I'm so happy that we did that. I don't know if it's used in the game industry. I do know that like our first party apps use MRTK. So I don't know how you define, I guess, VR games. I just can't say. I'm not sure. If I ever find one, I'll probably post it on my Twitter though.
Cool. Do we have further questions?
Hey, thanks for the great talk. I have a pretty specific quick question, and that's we are using the rigged hand visualizer that's in the experimental folder of the MRTK.
Yes.
And it basically maps the MRTK hand joints to the rigged hand model that has the same joints as the Leap Motion visualizer. We were asking ourselves why there's no prefab that has the exact same joints as the MRTK hand joints, and if that's something that's coming.
So Roger, I think he goes by Raj Podge in GitHub, just made a pull request to graduate rigged hands. I think it's rigged hands from experimental into full feature. So this is a very well, like he literally asked for feedback yesterday. And I love that we're open source because you can see all of that too. So I think he may have a solution, like he may have had to add a prefab that does this, but maybe not. I don't know why. The reason we add experimental features is because we have some number of people that are working on MRTK that need to like support a huge number of features, and we don't always have the time to finish all of them. So we put them in experimental first as a staging, and they just might not be, because they're experimental, they're not done in the way that we would want them to. So my answer is the reason that there's no prefab is probably because the designer that contributed it didn't think of it, and the engineers haven't had time to do it yet. And there's often, you know, if you think of something that should be done another way, you should always file an issue, and then you can actually make pull requests. I have reviewed, I mean, I regularly review, even though I'm not, you know, on the team, I regularly review pull requests from community members, and I love seeing community members contribute. So that's the answer.
Okay, yeah, cool.
More questions, please go ahead. Well, maybe then I go with it. I have also a lot of questions. I just don't want to steal all the time from the people. So one thing is also, I think it's that was a good point, is visual feedback, because you don't have haptic feedback, obviously. And I think it's good because in HoloLens 1 there was basically not so much feedback. You either clicked it or not, and if you didn't really hit it, then it was difficult. And now seeing that there is like really cool advance in basically having some proximity visualization and these kind of things, I think this is super useful. But I think especially for beginners, but also I also feel this like when I put on a HoloLens, which is not very calibrated to myself, that sometimes things are a bit off, and then it's really like missing. And I think one thing that's really disturbing is that the holograms are actually always flying on top of your hands also. So it should be easy actually because you're already tracking it to make like a hand segmentation to cut out things. So that would like really give you a feedback of where your hand is with respect to the actual virtual object. So is this something that there's a feature that is coming, or what are your thoughts on this?
Yeah, I think it's sort of having a hand rendering is something that can help with depth perception. And there's actually an app called MR Playground. It's in the store. Just look for Playground. Yes. That lets you experiment with how that feels. Actually, there's another app, I believe, called Graffiti that one of my colleagues wrote that also allows you, I believe, to experiment with occlusion. And you can basically see it for yourself. It's not hard to do in MRTK. And it's definitely super interesting. I can't make any further comments on it, but it can definitely help with depth perception. And there are apps that show how that feels. Yeah.
Yeah, and maybe as a follow-up question, since visual feedback is nice, is are you or someone in a team also like working into like haptic feedback in a way that, I don't know, you can imagine having like a glove? I mean, it's probably like an expensive piece, and it's probably research ideas now, but I could imagine that you have some haptics which are then actually nice, that you actually have some force feedback on your fingertip when you touch something or something like that. I think that would be like also like a great direction. Of course, is like more sophisticated hardware, and also like, of course, finding out like what is the right software then for this. But I think this is also like interesting direction. Is this also something your team is looking into?
This is something that people at Microsoft are looking at. There's Eyal Ofek and Mar Gonzalez, pretty active. They actually, I think, gave recently talks in the XR Bootcamp series that is around, I believe, haptics. They've been doing some really interesting research on, using various hardware to simulate haptics for a while. And that's the stuff that I know about,
Okay, so do we have more questions from the audience in the meantime?
If there's no questions, I just want to say that I try to be active on Twitter and share information about MRTK coding tips and interesting talks and videos that I find. So I would highly recommend, if you want to follow, random MRTK on HoloLens and mixed reality content, follow me, and also some of my other creators that are from Microsoft are here as well, included.
Cool. Maybe I have a final question. I was wondering, like, how much are you actually limited by the field of view of HoloLens? Because often you actually use your hands and do things which are actually not in your line of sight. But of course, you can steer it to some degree to kind of put objects there and so on. But I think especially if you want to create user interfaces which are like something that you don't need to learn or don't need to adapt to, that this is usually something I need to say to people when they use HoloLens. Like you have to hold your hands in front of the device.
Yeah.
So how much is this limiting to you, or is this like do you also have like ways around there to kind of like maybe add additional sensors in the future?
Yeah, I think that it's more limiting with far interaction than near interaction, because with near you usually like you see the thing that you're interacting with. I definitely think that to maximize comfort, it helps to have your hands like near your lap. And so it's something that is very hard to do, because we're, like increasing the visual field of view means more pixels rendered, which is a lot more pixels rendered, which can be hard. And then for the camera field of view, there's a lot of space to cover, and adding hardware adds weight. So there's a lot of trade-offs that we have to, and also power consumption, because you have to have a good battery life, and it can't be heavy, and batteries are heavy. So it's just like many challenges that you always are fighting with. But this is something that we're always working to improve. Yeah.
Okay, thank you. I see there is another question again from Samuel Lefebvre on YouTube. Do you have a book recommendation that you found useful for VR AR domain?
Yes. Yeah, so 3D User Interfaces by Doug Bowman. I read that several times. Brave Nui World, Brave NUI World. I read that once or twice. And then The Design of Everyday Things I read once, and I find that just like generally good for UI learnings. Yeah. But 3D User Interfaces covers a great deal of academic research, like the history of it. And it's, for me, was really useful to give me good base.
Okay, thank you very much. I think that's a good time now to summarize. And yeah, thank you very much for taking your time, sharing your thoughts, and sharing your knowledge and experiences. It was very great to have you. Thanks a lot. So I stop here, and hopefully to see you soon. And news from your team as well. Thank you.
Okay, thanks everybody. Bye-bye.